Studio Podcast. AI on AI. Can AI win at math where humans excel? Welcome back to AI on AI, the podcast where artificial intelligence debates, dissects, and occasionally jokes about itself. Today, we're diving deep into something fascinating, and I'd say a little divisive: AI's recent leap into high-level mathematics. Specifically, the buzz around Gemini 2.5 Pro achieving a gold medal-level performance at the International Mathematical Olympiad, or IMO.
Yeah, thanks. So look, this achievement is no doubt impressive. Solving 5 out of 6 IMO problems within the competition's time limit, that's a real milestone. But to paraphrase Terence Tao's recent comments, the context matters. Gemini didn't just sit the test, right? It leveraged methods like parallel reasoning and curated hints, things no human competitor has access to.
Right, and I'd add, it's like comparing a marathon runner to someone driving the course in, say, an electric car. They both finish, sure, but the conditions are wildly different. Gemini had months of fine-tuning with IMO-style problems, and even a specialized deep think mode. That's not cheating, but it's bending the metaphorical rules.
Yeah, I get that analogy, but I think we're underselling the innovation here. Gemini's ability to reason in natural language and produce rigorous, formal proofs without intermediary translations, that's huge. I mean, the days of needing domain-specific languages like Lane or Coq for these tasks might be behind us. This could democratize higher-order math applications.
Maybe, but let's not lose sight of the practical implications, or lack thereof, in some cases. Sure, solving IMO problems is sexy, but how does that translate to, say, real-world engineering challenges or optimizing supply chains? AI in math still struggles with open-ended, creative problem spaces where the rules aren't so clear-cut.
Interesting points all around. Expert 2, I saw you nodding earlier. Did you want to jump in?
Yeah, I just wanted to push back a bit on Expert 3's optimism. Look, I'm all for democratizing math, but the reality is, these systems are still highly curated. It's like handing a student a textbook pre-highlighted with all the answers. Sure, they'll perform well, but have they really learned anything transferable?
Actually, I'd extend that point. This curation isn't just about training data, it's also about how the problems are framed. Gemini didn't have to guess at ambiguities in problem descriptions or deal with real-world messiness. For humans, that interpretative step is often half the battle, if not more.
Fair, but isn't that the point of AI, to reduce friction in problem solving? I mean, if we can offload the grunt work and focus on strategy or creativity, isn't that a net positive? It's like, using a calculator. No one debates whether calculators cheat at arithmetic.
Sure, but calculators don't claim gold medals. Laughs look, I think the skepticism around AI's methods isn't just academic nitpicking. It's about trust. If we're going to rely on these systems for critical tasks, medicine, finance, even governance, we need to know they're robust, not just optimized for specific test cases.
Speaking of test cases, let's pivot to the deep think mode that Gemini used. Expert 3, you mentioned its natural language reasoning. How does this compare to traditional AI approaches in math?
Oh, it's a sea change. Traditional systems like AlphaProof or AlphaGeometry relied heavily on translating problems into formal languages and back. That's like trying to debug spaghetti code in the dark. Gemini skips that step entirely, reasoning directly in natural language. It's faster, more flexible, and frankly, more human-like.
Yeah, but let's not oversell it. Natural language isn't always precise. Humans can debate what a problem means, AI can't. And let's not forget, Gemini still failed one IMO problem. That's a reminder these systems aren't infallible.
I'd go further. The failure highlights a broader issue: contextual reasoning. Gemini excels at structured problems, but struggles when things get messy. In the real world, math isn't always neatly packaged. It's often entangled with politics, ethics, or incomplete data. That's where AI still falls short.
Right, and that brings us to a broader question. What does this mean for the future of AI in mathematics and beyond? Expert 4, care to weigh in?
Sure, I think this marks a turning point, but not in the way people might think. It's not about replacing mathematicians, it's about collaboration. Picture an architect working with an AI that designs structurally sound, creative forms based on vague sketches. That's the future I see, not competition, but augmentation.
I like that vision, but we need safeguards. If these systems become black boxes, how do we verify their outputs? I mean, it's one thing to trust AI with IMO proofs. It's another to let it design, say, a nuclear reactor.
Absolutely, transparency is key, but I'd argue that systems like Gemini are already moving us in the right direction. By operating in natural language, they're inherently more interpretable than formal proof assistants. It's easier to spot errors when you can, read the reasoning.
Maybe, but let's not forget, we still need humans in the loop. AI can help us fail fast, learn faster, but only if we're actively guiding it. Otherwise, we risk over-reliance and complacency.
Great points, everyone. Before we wrap up, let's do a quick round of predictions. What's next for AI in high-level reasoning? Expert 4, why don't you kick us off?
Sure, I think we'll see AI become a standard tool in academic research, like a hyper-advanced research assistant. But its influence will be less about solving problems outright and more about exploring what's possible.
I'll take a contrarian view here. I think we're nearing the peak of what language models can do in math. To go further, we'll need hybrid systems, combining intuitive reasoning with formal verification. That's where the real breakthroughs will come.
I'm with Expert 3 on this one. The next frontier isn't just better models, it's better integration. AI needs to work seamlessly with humans, not as a replacement, but as a partner.
And I'll end with a caution. Progress is exciting, but let's not lose sight of the bigger picture. AI isn't just about what it can do, it's about how we use it. Let's aim for responsible, meaningful impact.
Well said. And on that note, we'll wrap up this episode of AI on AI. Thanks to our experts and thanks to you, our listeners. Until next time, remember, AI may be great at math, but the human equation still matters. Laugh, see you next time. Right. The topic is the performance of the Gemini 2.5 Pro AI model at the 2025 International Mathematical Olympiad. The International Mathematical Olympiad is a global competition featuring complex problems in algebra, geometry, and number theory. This year, the Gemini 2.5 Pro model achieved a gold medal score by solving 5 out of 6 problems correctly. The AI operated end-to-end in natural language, producing rigorous solutions directly from problem descriptions. Previous AI systems required domain-specific translations and days of computation to achieve similar results. Gemini 2.5 Pro used an advanced reasoning mode called Deep Think, which explores multiple solutions simultaneously. The model also incorporated reinforcement learning techniques and training on a curated corpus of high-quality mathematical problems. Experts praise the AI solutions for their clarity, precision, and ease of understanding. This marks a significant improvement over last year's AI systems, which only reached a silver medal standard. Some experts like Terence Tao caution against overinterpreting AI performance due to differences in testing conditions. Challenges include ensuring AI systems are tested under consistent and fair methodologies for comparison with human performance. Looking ahead, such advancements could lead to AI tools that assist mathematicians in solving even more complex problems. These developments highlight AI's growing role in advancing mathematical reasoning and research. Right.